What if the most extraordinary worlds in our solar system are not the ones etched into every textbook? Mars, Jupiter, Earth, these giants rule our imaginations and dominate science classes. Yet while their names thunder through history, some of the most astonishing secrets are tucked away in places most have never heard of, waiting for those bold enough to look. These neglected worlds, enigmatic moons, distant ice giants, ancient asteroids, are far more than cosmic curiosities. In fact, they may hold the blueprints for how planets are born, the recipes for life survival in brutal conditions, and even the resources that could fuel the next leap for humanity. Overlooking them could mean missing out on evidence of alien life, revolutionary energy sources, or the very answers to Earth's mysteries. If we focus only on the familiar, we risk letting the universe's greatest revelations slip through our fingers. The true story of our solar system is not just about the planets you know. It's about the hidden wonders biding their time, ready to change everything. Think of how the discovery of microorganisms on Earth transformed biology, or how the first detection of exoplanets shattered our old assumptions about the uniqueness of our solar system. Ignoring these shadowy worlds could be like living before Copernicus, blind to the real structure of the cosmos. So, what are these shadowy worlds, and why are scientists racing to unlock their mysteries now? To answer that, we need to journey beyond the spotlight and into the unknown. Imagine a world where rain is not water, but diamonds, pressed from carbon by forces far greater than anything on Earth. Visualize vast, hidden oceans, not on planetary surfaces, but buried beneath miles of ice or rock, concealing alien environments that could rival the strangest science fiction. Picture volcanoes erupting, not with fire, but with icy slurries or unfamiliar chemicals, challenging everything we believed about how planets live and die. Consider the possibility that earthquakes, storms, and seasons play out in forms so bizarre they would seem magical to us. Uranus and Neptune, the ice giants of our solar system, are stranger than any fiction. While Jupiter and Saturn usually steal the show, these distant blue worlds may hold secrets that could upend everything we know about planets, here and across the galaxy. Unlike Jupiter and Saturn, Uranus and Neptune are not gas giants. Instead, they are ice giants, their bulk made up of dense, scalding fluids, water, ammonia, methane, wrapped around small, rocky hearts. Over 4/5 of their mass is a roiling ocean of exotic ices, squeezed by titanic forces into forms barely imaginable on Earth. Imagine the pressure at the core, more than 1,000,000 times that at sea level, enough to crush any earthly material. Their skies are wild. Neptune, for one, boasts the swiftest winds anywhere in the solar system, screaming at speeds beyond the sound barrier. Picture storms that could lap our planet in mere hours, only to vanish like phantoms after a few short years. These tempests churn just the upper atmosphere, leaving layers below eerily calm. Scientists suspect methane is the hidden engine, trapping heat and then releasing it in spectacular, unpredictable bursts. To put this into perspective, think of Neptune's Great Dark Spot, a storm as wide as Earth, observed by Voyager 2 in 1989. Unlike Jupiter's Great Red Spot, whose swirling fury has persisted for centuries, Neptune's storms are ghostly apparitions, emerging and disappearing in only a few years. Imagine a continent-sized hurricane forming over the Atlantic and then vanishing without a trace before a child could finish high school. Uranus, meanwhile, is even more bizarre. The planet does not simply spin, it rolls, lolling on its side as it orbits the sun. This leads to seasons more extreme than anywhere else. Each pole basks in unbroken sunlight for more than 2 decades, then plunges into darkness for over 20 years. Yet Uranus's atmosphere moves in slow motion. Its clouds and storms can appear years after the sunlight has changed, as if the whole planet is out of sync with time itself. Perhaps the most astonishing secret lies deep within both worlds. Under terrible pressure and searing heat, methane is ripped apart, letting carbon atoms fuse into solid diamonds. Yes, it may literally rain diamonds inside Uranus and Neptune, a phenomenon now recreated in earthly laboratories. This diamond storm could help explain the planet's strange energy and their wildly tilted magnetic fields. Consider the ancient cataclysm that tilted Uranus. Billions of years ago, a collision with a protoplanet, possibly as large as Earth, knocked Uranus onto its side. The result is a planet that experiences day and night like no other. For 21 years, a pole faces the sun in perpetual daylight, while the other languishes in a darkness that would stretch from the end of the Cold War to the present day. The aftermath of this collision is a world whose weather and climate remain a puzzle. To understand this, picture an experiment scientists at Stanford University recreated the conditions inside Neptune using powerful lasers to compress plastic to the required pressures. For a fleeting moment, tiny diamonds formed, confirming that diamond rain is not only possible but likely common inside these distant giants. These diamonds could sink inward, generating heat as they fall, further influencing the planet's mysterious energy balance. Ignore Uranus and Neptune, and we risk missing the keys to planetary behavior, how energy flows, atmospheres rage or settle, and magnetic fields take shape. These ice giants are not mere curiosities. They are natural laboratories for the universe's most common kind of planet. What happens here might echo across countless worlds, influencing the search for life and the future of human exploration far beyond Earth. But the ice giants are only part of the story. Orbiting and trailing them are moons and mysterious objects, places that could redefine our idea of habitability. Would you believe the asteroid belt conceals oceans and volcanoes, and that the moons of distant giants might be alive? The truth is even more astonishing. Far beyond the familiar planets, moons and asteroids are rewriting everything we know about water, life, and cosmic riches. This is not just speculation. Observations from the Kepler Space Telescope have revealed that Neptune and Uranus-sized planets are among the most common in our galaxy. By understanding the ice giants in our own backyard, we gain insight into the architecture of star systems everywhere. Their study could unlock the secrets of thousands of exoplanets, many of which might host their own moons, atmospheres, or hidden oceans. Look at Triton, Neptune's largest moon. Its tail begins with cosmic violence. Triton circles Neptune backward, a retrograde orbit that shouts of capture from the Kuiper Belt billions of years ago. That ancient theft was so fierce, it likely shattered every other moon in Neptune's grasp. But Triton refuses to settle. Instead of normal volcanoes, it sports cryovolcanoes. Icy geysers blasting plumes of nitrogen and frost, endlessly sculpting its frozen face. This frigid volcanism signals a restless, perhaps even active world lurking beneath a crust of ice. When Voyager 2 flew past Triton, it captured images of geysers erupting more than 5 miles high. These plumes, composed of nitrogen gas and dark dust, drift across the surface, leaving trails that crisscross the landscape. This suggests that Triton's interior is still warm enough to power geological activity, a remarkable fact for a world so far from the sun. Asteroids hold their own surprises. Ceres, once dismissed as mere rubble, is now known as an ocean world. Beneath its dusty skin, salty brine has lingered in a subsurface sea for billions of years. Hydrated salts on Ceres' surface are direct evidence. Recent leaks from its buried ocean, raising the chance of life in the unlikeliest places. Consider Vesta, a battered protoplanet scarred by epic collisions, and 16 Psyche, a massive metallic world likely exposing the iron-nickel heart of a shattered planet. These asteroids are not just fossils, they are treasure maps pointing to the solar system's hidden resources. In 2020, NASA's Dawn mission spotted bright patches on Ceres, deposits of sodium carbonate and other salts, likely left behind as salty water seeped to the surface and evaporated. This is direct proof that liquid water was present in the recent past and possibly continues to flow today. The implications are profound. Even small, battered worlds can maintain habitats for life. Missions like Dawn and Psyche are on a quest to uncover these mysteries. Their aim? To reveal how planets are built, how oceans endure the cold, and what wealth, water, salts, precious metals, awaits future explorers. 16 Psyche stands out as a world of metal. Its surface is thought to be made mostly of iron and nickel, the same materials that make up Earth's core. If confirmed, Psyche would be the only place in the solar system where we can directly study a planetary core without drilling miles beneath the surface. This gives us a window into the violent processes that shaped the terrestrial planets. If we ignore these wonders, we risk missing out on vast reserves of water and metal that could power humanity's leap into space. The stakes could not be higher: survival, prosperity, and the next giant leap beyond Earth. The story of planetary exploration is filled with such leaps. Consider how Galileo's telescopic discoveries ended the geocentric worldview, or how the Viking landers' search for Martian microbes transformed our understanding of planetary habitability. In the same way, these new missions could rewrite the rules of where life can exist and how planets evolve. But the greatest secret may lie beneath the icy surfaces themselves. What if these hidden oceans are not just reservoirs, but cradles for new forms of life? A cosmic gold rush is gathering momentum, but will it launch humanity to new heights or put our very future in space at risk? Imagine a future where a single asteroid could yield enough platinum to crash the terrestrial market, or enough water to refuel hundreds of missions to Mars. Companies like Planetary Resources and Deep Space Industries have already proposed plans to mine these cosmic bodies, betting that the first to tap these riches will shape the destiny of humanity in space. Scattered across the asteroid belt and the frozen outskirts of our solar system are treasure troves beyond anything mined on Earth. Some asteroids are loaded with more gold and platinum than all of human history has unearthed. Others hide veins of iron-nickel, exotic minerals, and, perhaps most vital, enormous reserves of water ice. This water is not just for drinking. In the vacuum of space, it is the raw material for rocket fuel and life support, the essential currency for any civilization beyond Earth. If we master the art of extraction, these resources could trigger a revolution. Picture a future where voyages to Mars, the Jovian moons, or even the edge of the solar system are launched from orbiting fuel depots, not burdened by the need to haul supplies from home. Asteroid miners and space industries could thrive, paving the way for permanent settlements far from Earth's gravity. The dream of a self-sustaining space economy would begin to look real. Yet, with riches come grave dangers. Mining in microgravity is untested and unpredictable. The technology is experimental, the financial stakes are staggering, and the rules governing this new frontier are almost non-existent. If corporations or governments race ahead without caution, the fallout could be disastrous, not just for the pioneers, but for everyone with ambitions in space. Unrestrained mining could shatter fragile asteroids, releasing storms of debris that hurtle through the solar system at many thousands of miles per hour. These fragments could cripple satellites, endanger missions, or choke the orbital pathways that connect us to space, potentially trapping humanity on Earth for generations. But these resource-rich worlds hold more than just profit. They are laboratories of the unknown, each with secrets that could redefine our place in the cosmos. We stand at a decisive threshold. Will we choose careful, sustainable exploration, or repeat old mistakes, letting greed and haste poison our future among the stars? The choices we make now will decide if we become true spacefarers or remain tethered to Earth by our own short-sightedness. What if the most promising cradles for life in our solar system are not planets, but icy moons lurking in the shadows of giants? History offers sobering parallels. During the California gold rush of the 19th century, Riches lured thousands westward, but environmental destruction, lawlessness, and conflict followed. If we repeat those mistakes in space, the consequences could be orders of magnitude worse. We must weigh progress against preservation, profit against prudence. Consider Europa, one of Jupiter's enigmatic moons. Beneath its thick shell of ice lies a boundless, briny ocean, containing more water than all of Earth's seas put together. This hidden ocean stays liquid, warmed by relentless tidal forces, and creates a realm where life might flourish. This is not science fiction. NASA's upcoming Europa Clipper mission is designed to do exactly that. If even a hint of biology is found, it will mark one of the greatest discoveries in human history. Europa's surface is scored by cracks, and sometimes it erupts with towering plumes of water vapor. These geysers could connect the ocean depths to the emptiness of space. For scientists, they are golden gateways. Sampling them might reveal the chemical fingerprints of life, no drilling required. Yet Europa is only the beginning. Saturn's tiny moon Enceladus has rewritten the story of habitability. Not long ago, spacecraft soared through colossal jets bursting from its south pole, jets teeming with water, organic molecules, and hydrogen gas. This is unmistakable evidence of hydrothermal activity, akin to Earth's deep-sea vents where life prospers without sunlight. These vents are more than geological oddities. They prove Enceladus is alive with energy. Here, warm mineral-laden waters meet a frigid sea, forging a habitat that could sustain entire alien ecosystems, no sunlight necessary. Water, energy, and organic matter, the core ingredients for life, all converge in this frozen wilderness. This revolutionizes what we thought possible. If life thrives here, sealed away from the sun, the universe may be brimming with hidden biospheres. Ocean moons like these are living laboratories, hinting that habitable worlds may emerge wherever water and energy collide, even in the coldest, darkest corners. On Earth, hydrothermal vents teem with bizarre creatures, giant tube worms, blind shrimp, and sulfur-eating bacteria, proving that life can arise and thrive in utter darkness. If similar processes are at work on Enceladus or Europa, it is possible that entire biospheres exist, shielded from the sun and the gaze of telescopes. But the stakes are immense. If we look away now, we risk losing our best chance to answer the oldest question: are we alone? If life waits beneath Europa's ice or drifts through Enceladus's plumes, our understanding of our place in the cosmos will be forever changed. Yet these icy moons are only the start. Beyond them, stranger worlds beckon, places where the rules of nature are rewritten in dazzling, unexpected ways. The universe's greatest secrets are waiting in the shadows. Will you help bring them to light? Or consider Pluto, once dismissed as a frozen rock, now revealed by New Horizons as a complex world with glaciers, mountains of water ice, and a thin, shifting atmosphere. Each new mission peels back another layer of mystery, reminding us that even the most overlooked corners of the solar system can astonish. Titan, Saturn's largest moon, a world with lakes and rivers, not of water, but liquid methane and ethane. Its orange skies rain hydrocarbons, and its surface is sculpted by weather utterly alien to Earth. In this frozen realm, chemistry could mimic the earliest conditions on our planet, giving rise to life as strange as it is resilient. Every question we dare to ask, every hidden world we choose to explore, brings us closer to rewriting what we know about life, energy, and our place among the stars. Remaining curious is not just about gathering facts. It is about joining the boldest adventure in human history. By stepping forward, you become part of the search for alien oceans, storms stranger than any on Earth, and the raw ingredients for life scattered across forgotten moons and distant planets. Your curiosity places you at the heart of a story where the next discovery could redefine everything we believe about the cosmos, and our future within it. So, stand with the explorers, fuel the questions, let us venture into the unknown, together, and help transform the mysteries of the universe into tomorrow's discoveries. But if we let curiosity flicker out, we risk losing our chance. We could miss clues to life beyond Earth, secrets of planetary birth, or resources that might one day carry us to new worlds. The stakes are immense. Curiosity drives the story forward, while indifference leaves us blind.